So another method of the bearing that you may have seen before has to do with this idea of a north-south line, and then you're always looking at some sort of acute angle. So let me kind of define how that works for us. We have if you see here, this says north 42 degrees east. Now what that means is we're going to be based on a north line, and we're going to rotate off of that northern line 42 degrees towards the east. That's where the north 42 degrees east comes in. Contrast that with here I have south 31 degrees east. So if I'm heading south, or not heading, if I have a direction pointing to the south, and I rotate 31 degrees towards the east, then I rotate towards the right. See, if I have this one here, south 40 degrees west, again, I am pointing towards the south. If I rotate 40 degrees to the left, which would be west of south, then I have this direction here. So when you see this kind of dual notation of both a north and a west heading, or a south and a west, something like that, it's telling you which method. It tells you you're either facing north and rotating off of that, or facing south and rotating off of that. So this example right here is going to utilize that concept. And really, this is not a difficult problem. The most difficult part of this problem is really setting up the picture. So it says a ship leaves port and sails on a bearing north 47 degrees east for 3.5 hours. It then turns and sails at a bearing south 43 degrees east for 4 hours. If the ship's rate is 22 knots, or nautical miles per hour, we want to find the distance from the ship, find the distance that the ship is from the port. So the first thing that we're going to do is we're going to at least identify the path the ship is sailing on. So we know that it starts out here. It leaves port. So we're going to let A represent the port. And it sails on a bearing north 47 degrees east. So if I draw a line representing north, and I rotate 47 degrees to the east, so I'm going to rotate 47 degrees to the right, then I've rotated to the east. So we have this heading here. That's where it's going. It then turns, so it went some distance here. I don't know really how far it went, but it stops here. We're going to call this point B. It stops here and it turns and sails on a bearing south 43 degrees east. So if it's here and I now rotate south 43 degrees east, I'm going to draw a vertical line representing south, and I rotate 43 degrees to the east. So I'm going to rotate in this direction 43 degrees again. So I have something like that. That's where the ship is headed now. So it left port, stopped at some location B, and then turned and went in this direction. Now we know that it travels for 4 hours, and so all we know is that it's down here. This is some C. That's as far as we've got. We want to know at this 4-hour length of time, after that 4-hour length of time, I want to know how far is the ship from the port. So I'm going to draw a line. This is what we want to solve for. You want to be careful that your drawing here, because I don't want to imply that my drawing is actually a perfect right triangle. I need to check and verify that this is in fact a right triangle, because that allows us to know what type of, how do we proceed with the problem. As long as we know we have a right triangle, we have options that we can use. So how do I determine if this in fact is a right triangle? Well, going back to a previous example that we talked about, we can use parallel lines again, and the idea that if I have two parallel lines, so here I have a north line and a south line. Well, these two lines are both vertical and they would be parallel to each other. They are cut by this transversal here, right? So I have this line passing through B, this line passing through A, which would be parallel to each other, and they are cut by a transversal. And if they are cut by the transversal, then the angle here of 47, interior angle here of 47 degrees would be the same angle here of 47 degrees. So I'm just going to write that down. So if this is 47 degrees on the left side of this vertical line, what would angle B would have to be 47 degrees from this yellow highlighted part that I added, plus the 43 degrees that we already know that we rotated. And 47 plus 43 does equal 90. So therefore, I do have a right angle here at angle B. And that's good to know because that means if this is a right angle at angle B, this is obviously then a right triangle. And we can go on and we can apply what we know about right triangles. Now, the other piece of information that we were given in this problem has to do with a speed at which we are traveling. And so if we know that we are traveling at some speed, then we can try to figure out what the rate is. Not the rate, the distance. So we need to remember that we have distance is equal to rate times time. We have a rate of 22 knots and we have a time of 3.5 hours for A to B. So let's kind of do a little math here. I know that if I travel from the port to my turning point, I've traveled for a 3.5 hours at 22 knots. It says the ship's rate is 22 knots. So 3.5 times 22 is going to be 77. So the distance would be 77 kilometers. Whoops, 77 kilometers. So from A to B is 77 nautical miles, not kilometers, miles. Now, let's see, how far was it then that I traveled from B to C? So from B to C, I know that we traveled for 4 hours at, again, a rate of 22 knots. Therefore, we would have traveled a distance of 88 miles. So here we have 88 miles. Now, because we know that this is a right triangle, I don't have to do any trigonometry. All I have to do is use Pythagorean's theorem to find out what the hypotenuse is here. So my distance from A to C is going to be the square root of 77 squared plus 88 squared. And when we put that into our calculator, we find out, rounding to the nearest integer, we find out that it's 117 nautical miles. So in other words, this hypotenuse here ended up being 117 miles. So again, the idea behind this problem is not so much about trigonometry as it is right triangles, and the most difficult part of it is just setting up an image of what was going on.